We're going to oxidation number now. Oxidation number. Now, what is oxidation number? Right. Oxidation number is the number assigned to an atom in a molecule or in a compound. Oxidation number is the number assigned to an atom in a molecule or in a compound that represents the number of electrons it has lost or it has gained. That's what oxidation number. That's an oxidation number. We'll be taking some examples that you can understand it better. Take some examples. Question number 1 under oxidation number. Question number 1. The oxidation state of chlorine in potassium chromate is what? The oxidation state of chlorine, potassium chlorate. Potassium chlorate is. That's just the question. Now, the issue here is, what is the compound, the formula for potassium chlorate? If the formula for potassium chlorate is C. Now they say we should find the what? The oxidation number of chlorine in this compound. What will you do? First things first. Please understand though, understand. These are the basics, understand. The first thing first you will do is, what is the combining power of potassium here? 1. Combining power is valency. Valency is the combining power of an element. So the valence electron of potassium is what? 1. How? Potassium is number what? Is it 19? Potassium is number 19. Follow. 19. If we put it in the first shell, it will have 2. The second shell will have what? 8. The next shell will have, that is 8. This is 18. So the next one will have what? 1. So 1 is the valence electron. So 1 can be said to be the combining power of this potassium. You understand me? You understand? You understand? Oxygen, let's take oxygen. Oxygen is what? Number 8. We take 1. That is the first shell. So to take the next shell will be what? 6. Hold on. Don't rush. Hold on. For oxygen, because of it is non-metal, the combining power is not what it gives out, it's what it receives. What does it receive to make it 8? It receives 2. So let's say plus 2. Plus 2. It will be 2, 8, 2, 8. But that plus 2 it receives. Now, this is the confusing part, but don't be confused. That plus 2 it receives, it will be what? Minus 2. Are you getting it? Now, when an element receives, that thing it received becomes minus. If it receives 100, it becomes minus. The Bible says it's not blessed to give than to receive. So when you give, God blesses you. Are you getting me now? So this guy will give out this one. Potassium will give out this one. To become positive 1, it will be plus 1. Because he gave out what? 1. You understand? Favor, you understand? Oxygen will take 2. So he's not blessed. Are you getting me? He's not blessed. He's what? Minus 2. You understand? So can you solve this? Let's solve. The combining power of potassium is plus 1. We are looking for chlorine. Then remember, oxygen is what? Minus 2. Minus 2 times 3. All equals to 0. Understand? Follow. So we have plus 1 chlorine. This plus this will be minus 6. You understand? Jerry, are you with me? This is what? Minus 6. Now, you collect like terms. You move, chlorine is here. You move all these ones because of their integers now. This is an integer. So you move all of them to this other side. It will be minus 6 will change to plus 6. Plus 1 will change to what? Minus 1. So we have chlorine to be, which will be plus 5. Chlorine is what? Plus 5 in this compound. Chlorine is plus 5 in this compound. Right. I hope you understood that point of, if you collect, you become minus. What you are collecting is minus. So if you give, what you are giving is plus. Next question. Next, this subheading has plenty questions, so follow me. Next question: what is the oxidation number of manganese? Manganese, not magnesium, manganese in potassium permanganate. What is the oxidation of number of manganese in potassium permanganate? Issue here is what? To form the what? Chemical formula. That formula, that's the issue. Potassium permanganate. Potassium permanganate is KNO4. Potassium permanganate. The formula for this stuff for potassium permanganate is KMnO4. This Mn is what we are looking for. This Mn is what? Manganate. So they say we should find the oxidation number of manganate in potassium permanganate. Can we solve manganate? Is KNO4. So we have K to be +1. Mn, that's what we are looking for, plus Mn. Plus, remember, you add this plus first, so before you do, -2 times 4. So this is +1 plus Mn minus 8, all equals to 0. We collect like terms. Collect like terms. We collect like terms. We have Mn is equal to 8 minus 1. So Mn in this compound is equals to what? +7. Abi? Right, +7. That's just it. Right. What is the oxidation state? What is the oxidation state? What is the oxidation state of chromium? Chromium. What is the oxidation state of chromium in potassium chromate, which is this chromium? Oh, see, hold on first. When you find the oxidation state of this stuff, you can now name the compound easily. This is potassium heptaoxochromate something. When you find the oxidation state, that's when you can name it fully. You get? So when we find the oxidation state, you can name it. Have potassium to be +1. These two here, understand? Plus chromium plus oxygen is -2 times this 7 here, all equals to what? 0. We go on. This is 2 plus chromium minus 14, all equal to what? 0. We move this to this side, collecting like terms. We have chromium is equals to 14, which is +14 minus 2 is equals to what? 12. So we have chromium to be equal to what? 12. We are not done. Are we done? Are we done? Remember, this chromium, they say chromium, they don't say chromium 2. They say chromium. So we divide both sides by 2. So chromium is therefore equal to what? 6. Do you understand? Therefore equals to 6. So can someone name this compound? Yes, someone can name it now because the oxidation state of chromium has been known. So let's name it. This is potassium heptaoxochromate 6. You get? This is the IUPAC way of naming it. But if it was in olden days, they will call it potassium chromate. Finish, potassium chromate. That's why that one that we did, that was potassium manganate, permanganate. Please, can you name it in this IUPAC way? Please. That is potassium heptaoxomanganate what? 7. That's just it. That's the IUPAC nomenclature of naming. It's oxidation state that help us to know that stuff. Go to the next one. They say the oxidation state of boron. The oxidation state of boron in this compound. What is the oxidation state of boron in this compound? What is the oxidation state of boron in this compound? What is the oxidation state of boron in this compound? Listen, I think when hydrogen reacts with a metal, it will be acting as what? Negative, not positive. Are you getting me? Don't see it as negative, it's writing as positive because this is positive. Sodium chloride. This is the positive, this is the negative. So watch out for this kind of stuff. So these two are metals. So this one has plus, this one has plus. This it should be the one that will be the minus to form a balanced equation. So you get me? Understand? So if this is plus 1 plus b plus minus 1 times 4, we have all equals to 0. We have 1 plus b plus minus 4 equals to 0. We cross over. We have b to be equals to 4 minus 1. B is equals to plus 3. Now, note, the reason why we took hydrogen to be minus is because it's reacting with metals. So him will be the minus.